we're talking about respiratory organs in the different organisms. Getting it now? Okay, one of you posed a question like, what was the function of the structure in the earthworms that look like this? Okay, like there was a swelling in the body of the earthworm. Somewhere it looks like this. If you were to look at this diagram, that's a proper depiction can be shown here, right here. Look here. This structure that you see here in the earthworms, that is actually called as clitellum. That is called as clitellum. So what is this clitellum? It's a it's like a thick saddle-like structure. Okay, made up of rings, different rings. Okay, and it is found in the epidermis, that is in the skin of the earthworm. This is a saddle-like structure called as clitellum that is found in the skin of the earthworm, and its function is to store the eggs that are produced by the earthworm. Getting it now?
Yes, sir.
So while the
Yes.
earthworm is about to mate with another earthworm in the process of reproduction, thereby whatever eggs are being secreted, eggs are being stored by the clitellum, by the earthworm in this clitellum. Getting it now? Okay, so that is the function of this clitellum here. Okay, now moving on, we have got the exercise part. Let's discuss that, and then we will be beginning with a new chapter once we are done with this. Okay.
Sir, can you like zoom more? I can't see properly.
Yeah, I will be zooming it. Yeah, is it visible now?
Yes.
Yeah. Question number one. Question number one. Vaiga, you see this question. Why does an athlete breathe faster and deeper than usual after finishing the race?
So the first one, right?
First one, question number one.
Like while running, like athletes need
After the running, yeah.
like energy in their like muscles and cells for the extra work.
Mm-hmm.
Like they should breathe more faster and deeper,
Mm-hmm.
so that like there'll be more oxygen is supplied to the cells.
Mm-hmm.
Like this will speed up the breakdown of food,
Mm-hmm.
so like more energy will be released.
Okay. Exactly.
Yeah.
Look here. While the athlete was running, okay, during that process, all the oxygen that was being taken up by the athlete, in the process of breathing, majority of the oxygen was utilized to provide the energy to run, right? So now once the race has been finished, the person still breathes very heavily, takes a deep breath, because the person is now tired and all the energy has been exhausted. Okay, so person needs more energy. In order to generate more energy in the cells, as you said, the person needs to take in more oxygen to fasten up the process of respiration. And also, after doing a heavy exercise work, person feels a bit hungry. That is the answer. Okay, next, Chakrika, you mentioned the similarities and differences between aerobic and anaerobic respiration.
Okay, sir. So aerobic respiration is like okay. In aerobic and anaerobic respiration,
Mm-hmm.
like both of them can happen in humans
Yes.
and
Okay.
animals.
Mm-hmm.
But then the thing is that in anaerobic respiration, we only get like 5 ATPA, but then in aerobic respiration, we get 38 ATPA.
Okay, look, Chakrika, you should now first start from the, like, if you look at the term aerobic, anaerobic. Aerobic, that is in the presence of air. Anaerobic, that is in the absence of air.
Absence of
So
air.
first you have to start making difference from there, from the basic point, that is the respiration that takes place in the presence of oxygen, and then the
Yeah.
opposite. Yes, continue.
Okay, sir. Okay, sir. Yeah. So in aerobic respiration, we use air, like in the presence of air, and in anaerobic respiration, it is in the absence of air. And in aerobic respiration, energy, carbon dioxide, and Yeah, energy and carbon dioxide are released, sir. And in anaerobic respiration, for suppose if it's animals, like for suppose yeast,
Mm-hmm.
alcohol, carbon dioxide, and a bit of energy will be released, sir.
Look,
And
these
then
are not, these are the products formed in the two types of respiration. The second point you should be mentioning that in the aerobic respiration, higher energy is released,
yes, sir,
more energy is released, and
and
here less energy.
lesser energy.
Yeah, continue.
Yes, sir. And then if it's in humans, then lactic acid and just a bit energy, and then carbon dioxide are released, sir.
Okay, good. In aerobic respiration, high energy is released, and you say that some products are also released. Okay, in aerobic respiration, that takes place in the humans, or whether it were to take place in plants, same products are released. That is, what are the products?
Sir, energy, carbon dioxide, and
Water is
water
also
too. Yes, sir,
water
and water.
plus 38 ATP molecules of
ATP.
energy. While in the case
Sir,
of
you
aerobic,
said one time 36 ATPs, and then second time
oh, okay,
38
okay,
ATPs.
36.
I do not
I
understand. I
It's
guess
36,
36 are there.
36. It's 36, 36. Okay, 36. My bad. Now, anaerobic respiration, here carbon dioxide is released. If you were to take the example of uh, yeast powder, if you were to take the example of yeast, the carbon
And
dioxide is released and then alcohol is also
alcohol.
released. Okay, apart from energy. Getting it now? So only 5 ATP molecules of energy are released there. While in the case of human, as you said, lactic acid is released and then energy is released. Later on, after taking a warm bath or after massaging the area, this lactic acid might break into what? Sundus, you answer this.
Carbon dioxide. Oh, sorry, sir.
Carbon dioxide, carbon dioxide and
And so water.
water. Good. So these are the differences between the two. While anaerobic aerobic respiration is, if you were to see here, talking about aerobic respiration, it's a comparatively a slower process. It's comparatively a slower process, while anaerobic respiration is a fast process. You can add one extra point here. This one is slower process. This one is a faster process. Got it now? Okay. Next question. Vaiga, you see this. Sundus, you see question number 4. Read the question and what does it says? Question number 3 actually. Why do we often sneeze when we inhale a lot of dust laden air?
Like we feel irritation in the nose.
Mhm.
That's why.
What happens?
We feel irritated in our nose. Like we have hairs in our nose for that. Like
Hmm.
it protects like the dust and
Hmm.
things to
Hmm.
come inside our nose.
Hmm.
And that's why we feel.
Hmm. Okay. So inside our nose, you have got the hair lining. Okay, as you said, and then you have got this nasal passage. This is the nasal passage here that you are seeing. And in the nasal passage, okay, what happens if someone were to, let's say, inhale a dust particle, a pollen grain, for example, okay, then the inner linings are irritated by this dust or pollen particles, pollen grains. Getting it now? The particles, if they manage to get past the hairs, then they will be irritating the nasal cavity or the nasal passage. That's why person will be sneezing it. Okay. Question number 4. Why read the question? What does it says?
We have to take test tubes, fill three by
Mhm.
fourth of each with water, label them A, B, and C. Keep a snail in test tube a water plant in test tube B, and in C keep snail and plant both. Which test tube would have the highest concentration of CO2?
Yes. What do you think? We have
Uh,
taken 3
so,
test tubes here, right? Mhm.
so I guess A will have the highest concentration of CO2.
Hmm. You have
Because
put snail A. Yeah, go
like
on. Hmm.
nail is the organism that breathes in O2 and breathes out CO2,
Exactly. It will be taking in oxygen while giving out the carbon dioxide.
carbon
While
dioxide.
in test tube B, it says that a water plant is being placed in test tube B. While in C, what you have put in C, you have kept both snail and plant. So test tube A will have obviously the highest amount of concentration of carbon dioxide, right? While
Yes, sir.
in test tube B, you have placed a water plant. So plant, in this case, what will happening? Hmm?
Like plants take in
CO2 will be
CO2
hmm,
and gives out O2.
exactly, plants will be taking in the CO2 to
Yes, sir.
utilize it, getting it now. While in the case C also, the CO2 that is being given out by the snail will be taken up by the plant right now. So test
Yes,
tube
sir.
A will be having highest concentration. Okay, why Chakrika, see question number 5. First one of question number 5. In cockroaches, air enters the body through which part?
Sir, spiracles.
Sparicles. Sundus, you answer me that what is the site of gaseous exchange in cockroaches?
Trachea tubes, sir.
Tractal
Trachea.
tubes. Exactly. Okay. Vaiga, question number B. During heavy exercise, we get cramps in the legs due to the accumulation of
Lactic acid.
lactic acid. Okay. Vaiga, question number C. See this question. Normal range of breathing rate per minute in an average adult is how much?
So 15 to 18.
15 to 18 times. Good. During exhalation, ribs will move downwards or move upward. Like inhalation is a passive, it's a active process in which energy is required. So we lift up the ribs, right now,
It
to
moves
inflate
downwards.
the, it moves downward while
Downward.
we exhale the air out. So moves downward. Good. Okay. Question number 6. Match the column 1 with column 2 here. East. It produces what? Okay. The question is to Chakrika. First, you answer the question number A.
Sir, alcohol.
Alcohol. Good. Sundus, diaphragm is related to what? Mhm.
Lungs and
Yes.
lungs. Say chest cavity, chest cavity.
Chest cavity, no?
Yeah.
Okay.
Correct.
So if it moves upward and downward, it increases or decreases the chest cavity. Then skin. Viga.
Earthworm.
Earthworm. Good. Chakrika, leaves.
Sir, stomata.
Stomata. Good. Sundus, fish have got which organs?
Gill.
Gills. Good. Frog have got both
Lungs and skin.
lungs and skin. Okay. While seahorse, someone asked this question. Seahorse only have got gills. Only gills. Okay. They don't have. They don't breathe through their skin. Okay. Trachea. It is the organ used by the cockroach. Getting it now. Hmm. Now, question number 7. First question. Vaiga, read the question. What does it says? During heavy
During
exercise,
heavy exercise, the breathing rate of person slows down. False.
obviously false. So the second one, plants carry out photosynthesis only during the day and respiration only at night. Is the statement true or false?
False. False. They
It is
focus.
false. Hmm. False, because respiration is a 24-hour process, right? Okay. Question number 3. Frogs breathe through their skin as well as their lungs. Yeah, Chakrika. Third question.
It's true, sir.
It's true. Vaiga, next question.
The fish has lungs for respiration. It's false.
Obviously false. Question number 5. The size of the chest cavity increases during inhalation. During inhalation, the size of the chest cavity increases or decreases.
please.
It size of the chest cavity increases now. In the case of inhalation, we inflate our ribs, thereby allowing the lungs to expand, and the diaphragm lowers down. Diaphragm comes down, no? Yeah, isn't that what happens? Yeah, hello,
Yes, sir.
right now. So
Yes.
in thereby increasing the chest cavity, so it allows more air to enter into our lungs. So that statement here is true. Question number 8. Find the terms and the clues are given here. Okay. The air tubes of insects, that is called as what?
Tra-
That is
Sir, is it trachea?
Trachea tube?
air tubes through which
Yeah.
they are taking in air from the surrounding.
Sir, but then it's given trachea, right, over there?
Trachea is given there.
Yes, ma'am.
Yeah,
Yes, sir.
trachea is given there. Then you see spiracles are also given there. Trachea,
Sir.
as we discussed, it's the site of gaseous exchange. It's not the air tubes. Okay, now. So the air tubes, if you were to look at the structure of
Okay,
the
sir.
cockroach again, the air tubes, the sieves here. Yeah, the spiracles here, you see. Yeah, the spiracles here. These are the hollow tubes through which the air is entering their body. All right now. Okay, so the first one is spiracles. Skeletal structures surrounding the chest cavity.
Ribs.
Obviously, ribs. Muscular floor of chest cavity. What do we call that?
Diaphragm, sir.
Diaphragm.
Diaphragm. Small openings on the sides of the body of an insect.
Stomata.
Tomato.
Small openings on the sides of the body of
Sir,
an
pores.
insect.
Sorry.
Pores.
Pores. Pores are different thing. It's spiracles. It's going to be spiracles. Okay. Then the respiratory organ of human beings. That is obviously lungs.
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 Okay. The
So you missed the
openings.
fifth one.
Fifth one. No, the fifth one we discussed now. Oh, fourth one I
Like the,
missed.
yeah.
Fourth one I missed. Tiny pores on the surface of leaves. That is stomata.
Yes,
Yeah.
sir.
Sixth, seventh one, the openings through which we inhale.
So
Yes.
nostrils.
It's the nostrils, obviously.
Sorry.
Nostrils. It's in
Sorry.
we humans. Okay. An anaerobic organism. Give an example of anaerobic organism.
Yeast.
Yeast, obviously. An organism with tracheal system.
And
Cockroach.
And cockroach. Both are the examples. Okay. And slash cockroach. Okay. Question number 9. The mountaineers carry oxygen with them because at an altitude of more than 5 kilometers, there is no air. Is that true? At an altitude of 5 kilometers, there is no air. That is false now.
False. So the B is the correct answer.
The amount of air available to a person is less than that available on the ground. Exactly. Option number B is the correct answer. Right. Okay. So in this manner, the chapter finishes. Okay. So we discuss different points in the chapter. Okay. So what are the things which we discussed in the chapter? We talked about types. What is respiration? What are the types of respiration? Okay. How respiration takes place in humans? Okay. Then what basically goes on in the process of respiration? The reactions, we have talked about it. Getting it now? Then how respiration takes in? Yes.
Mechanism of breathing.
Mechanism of breathing, exactly. We discussed that as well. And how respiration occurs in underwater animals and underwater plants, and how respiration occurs in plants as well. Okay, by the way, respiration in underwater plant, they also take in oxygen, dissolved oxygen in the water by the process of diffusion also. Getting it now? And interestingly, they can also perform photosynthesis. The underwater plants, they also perform the photosynthesis. They also do the photosynthesis. Okay, because whatever sunlight reaches the bottom base of the water bodies, the plants are able to perform photosynthesis from that limited amount of sunlight only. Okay, so with this, the chapter finishes. Do you guys have any confusions in the chapter? Also, in human cells, which cell organelle is responsible for doing the process of respiration?
Lungs.
In human cell, CELL, in human cells, which cell organelle is responsible for respiration, which helps in the process of respiration? Its name starts from M.
Mitochondria.
Mitochondria, exactly. That is the site of respiration in human cells. Okay. So with this, the chapter finishes. Which chapter is next? Respiration we have discussed. Okay. One of you please
We are
tell me the
going through the
syllabus.
syllabus,
So
right?
let's start with motion and time.
Motion and time.
Yes,
Okay.
sir, because it's there for exam.
Okay. What about you, Vaiga? What about you, Chakrika?
Sir, for this term, actually, I have
Mhm.
light, sir.
Light.
Yes, sir.
Okay, light. Okay. When your exam is going to be, Chakrika?
Sir, I think it's in November, sir.
It's in November. And
But
what
the date
about?
is not confirmed yet.
It hasn't been confirmed yet. Okay. And what about you, Vaiga? When your
So
exams are
this
going to be?
October.
This October.
Yes,
Okay.
sir, it's so close.
Hmm. So
And
what
sir,
we can do now? Mhm.
we've discussed nutrition in animals already, right?
Nutrition in animals. I guess we discussed that where we talked about the
Uh,
types, different processes
yeah, yes,
involved in
sir,
the
we
process of
discussed.
nutrition: ingestion, digestion, absorption, assimilation, and excretion. Okay, and we
Yes,
talked
sir, we
about,
discussed about it. The
yeah.
digestive system of human beings.
Hmm. Okay. By
Yes,
the
sir, we
way,
discussed.
do you guys recall the name of glands? At least name few glands which are present in
Sir,
human
I
body.
know.
You
So
don't. Salivary glands.
glands,
Hmm.
liver and pancreas, sir.
Liver and pancreas are there. Good.
Yes, sir.
Sir, can
Apart from that,
gallbladder can be included?
no, gallbladder is not a gland. Okay, gallbladder, simply its function is not to store the bile juice. Okay.
Then there are just
Yes,
three
sir.
glands, right?
Mm-hmm.
There are just three glands, right? Salivary glands, liver, and pancreas.
Apart from that, you have some more glands also. For example, pituitary gland is there, adrenal gland is there. Okay, pineal gland is there, thymus gland is there in our body. Okay, the the three glands which I told you, these glands are the only glands that are associated with the process of digestion. Okay,
Yes, sir.
so you have got salivary gland, pancreas, and liver that help in the process of digestion. Their secretions help in the process of digestion. Okay, for example, the saliva helps to convert the carbohydrate into starch. Partial conversion into starch takes place in our mouth, for example. Then you have other glands in our body that has got different functions to perform. For example, you have got the pituitary gland that is in the brain, that is the master gland. Okay, and that gland is responsible for that gland secretes growth hormone. So if, let's say, if the secretions by the pituitary gland is much more, if they secrete much more amount of growth hormone, then the person will be gigantic. You must have seen, like in like there are people who are of more than 6 feet, like they are of 7 feet, 8 feet people, right now. In Guinness World Record, you might have seen that some people have
Yes,
who's, yes,
yes.
or then there are people who are like only like 2 to 3 feet. Okay, they are high, their growth was distorted, it was limited because not sufficient amount of growth hormone was secreted by the pituitary gland in their body. Okay, so there are not just three glands, there are so many glands in the body. Anyways, that's a separate
Okay,
discussion
sir.
right
So
now.
it's like if like we eat food, then only they will like give us the sufficient amount for us.
If we take in sufficient amount of food, only then they will be releasing the growth hormone. Is it what you are saying?
Yes.
No, that is not the case. That is not the case. For example, like if you were to see, there's a woman who has got the world record for smallest height in the world. I suppose she's from India.
Yes,
Okay,
sir.
she's from India, and usually we say now that people have developed conditions. For example, rickets. For example, different conditions are there that are developed in person due to malnourishment. Okay, if they belong to very poor family where the child was not given proper food and care, then the child might develop certain conditions. But this case, where the of dwarfism, okay, it is genetic. Okay, it is genetic. It is due to some genetic problem. The parents might not have that problem, but the child might have that problem because of some genetic issues. Okay, so Vaiga, your chapter is motion and measurements, right?
Not motion measurements, motion and
Motion
time.
and time. Motion and time. Okay, and since Chakrika, your exam is going to be in November, we can cover the chapter light after this. Is it okay?
Yes, sir, sure.
Okay, so let's begin the chapter.
Sir, I have a doubt.
Yeah.
Sir, are we going to learn something in chemistry?
In chemistry, yeah, obviously we will be beginning with that, with chemistry portion as well.
So, which chapter?
The chapter, uh, it will be according to you guys. Okay, whichever chapter is going to be coming in your syllabus, the class will be according to that as only.
Actually, sir, for me, it's like it's not from the textbook, sir. We're getting it out from the textbook.
Okay, you mentioned that. I think it was elements
Like
and like.
elements, yes, sir. Periodic table and the elements and stuff.
Okay.
Yes, sir.
So
So like I'm
if
having
it's
water precious resource.
water, a precious resource.
Yes, sir.
Okay. Okay. So Chakrika, we will see to it. We will cover that in a separate class, or if in possible in this class, or I think it's better to schedule a separate class for that chapter. Okay, because since it's not
Sir,
part of the
you can go
syllabus
on with
for. Mhm.
Vegas, sir. Vegas.
Yeah, Vega, if you are comfortable, we can go on with that chapter. And
Yes,
so,
I'm okay with any of the chapter. It's fine.
okay, and yeah, Sundus, you have to say something.
No, sir, I'm okay with that chapter.
Okay, so let's start with the chapter motion and time today. Okay, motion and time. Before we talk about motion, there are a few things we need to be aware of. For example, what do we understand when I say something is at rest? Hmm. Suppose there's a block of wood placed on a table here. Okay, let's say I placed this piece of brick on this table. Let's say I place it here at, let's say, 12 o'clock. Let's say at 12 p.m. Now the time has passed for 10 minutes. Okay, it has passed for 10 minutes, let's say. Okay, now the time is 10 minutes here, but still this brick is lying on the same place. So here I say the position of the object, if it does not changes with respect to time, then the object is said to be at the state of rest. Right now,
So
are
you
you guys?
just talk about the break
Oh
or
yes,
like
sir.
other things that are normally there.
I've just taken an example. It could be anything. It could be a piece. It could be a bottle lying on your table. Okay, it could be a water bottle lying on your table, or it could be anything. Just look at your house. Has it moved? It remains there now. So that's a stationary object. Okay. So we
So
say
like
that.
while we are sleeping,
Hmm, yep.
so it's like
While we are
sleeping an example for
sleeping,
rest.
while we are sleeping, while
Okay.
you and we, I are,
We
while we are
can
sitting
count in
on a
humans
chair,
too.
we can
We can count in humans too that rest.
we can count the human.
Humans too, in like the rest.
Yeah, human stool, anything that is not changing its position. Okay, it could be doing some movement. It could be doing some movement. Like I'm sitting here, I'm doing certain movements with my hand. Okay, I'm speaking, I'm doing my movements, but my position is not changing. Okay, I am sitting here, I'm not changing my position while the time is increasing. Okay, like 30 minutes have passed, but still I am sitting here. So in the same example, this object brick here, I placed it on a piece of table here, let's say at 12 p.m. But after 10 minutes also, this piece of brick was lying at the same spot. So we say that if the position of an object does not change with respect to time, we say that it is at a state of rest now.
Rest.
Yes. Sir,
Okay. Mhm.
Rest.
like it stays in the same place, but then the time goes on.
Exactly. The time goes on, but it stays on the same place right now.
So then, like sleeping is not an action of like a rest.
Like you do certain
It
movements
cannot be
in sleeping.
considered rest, right, sir?
It cannot be considered rest because you see, the person moves a slight bit.
Yes,
Okay,
sir.
and sleeping
Exactly.
also. Okay, the person won't sleep like a stationary or a dead object. Right now, the person
Yes, sir.
does. They take in roles. Getting it now. So if the position of an object does not change with respect
Well, like
to
this
time.
times have a limit or not?
No, it does not mean the time has to be an limit. Okay. Even if the time is for like 30 seconds, for 30 seconds, if the object has not changed its position, then I will say that this object during this time was at a stationary position at the state of rest. The time is not a boundation.
The sitting will come, right?
Sitting will be there. Sitting will be also an example of of a state of rest, right? So if the position of an object does not change with respect to time, it is said to be in a state of rest. Getting it now? Now suppose now in the next scene, what I have done, I have placed this brick on a toy cart. Let's say this is a toy cart and I have placed it here. Okay. And I have slightly pushed it. Due to some force, it is, let's say, this starts to move. Now the time here was 12 p.m. Okay. Now I pushed it, and after 1 minute, let's say 12 hours, 1 minute, the position now shifted to here. The brake is now lying here. Yeah. So here you see the time was also increasing. The time has also increased, while the position has also changed from point A to point B. Yes. The time has increased by 1 minute here, and the position has also changed from position A to position B. This cart carrying the brick has moved from point A to point B. So what do you observe here? Yes.
Smoother.
Hmm? We observe that this object has started to move from its state of rest and change its position from A to B. Okay. So during this 1 minute,
Minute is
hmm,
gone.
during this 1 minute, this object was in a state of motion. Right now. Now after some time, this cart will stop. Then again, it is back to its position of rest. Is it clear to all three of you
Yes, sir.
right now? So then in this case, we say that object is at a state of motion. Okay. We say that object is in motion. So how do you define this? If the
So we can say that, sir, that like the motion is opposite of rest.
exactly, we can say that motion is just opposite of rest. Right now, if the position of an object changes with respect to time, then it is said to be in a state of motion. It is said to be in a state of motion. Got it? All right. Now, motion can be relative. Motion is relative. What do I mean by this now? Motion is relative. Yeah. For example, Sundus and Chakrika are traveling on a train. Or for example, let's say on a bus. Okay, this is a bus in which Sundus and Chakrika are traveling together. And outside, Vaiga is looking at them. Vaiga is standing side by and looking at this moving bus. This here is, let's say, Vaiga, and here Sundus and Chakrika are sitting here. All right, now, if I were to look inside this bus, I will see that both Sundus and Chakrika are at rest now. Hmm?
Yes, sir.
Yes,
Can
sir.
you say again?
I see that let's say in this bus, Sundus, you and Chakrika are traveling to somewhere. This bus is moving. It's not stationary. The bus is moving. Okay, now Vaiga is standing outside on the bus, and she's looking at the moving bus here. Now, if I were yeah, sorry. Now, if someone were to look inside this bus, okay, let's say there's a passenger number. Let's say I am here. Okay, let's say I am standing here. So I will say that both Sundus and Chakrika are at a state of rest inside this bus. Because
Yes.
Sundus, you were sitting in your chair number, let's say A, and Chakrika is sitting in chair number B. And the bus,
So
let's say
it's like
bus,
that. Like it's like the person sitting inside is rest, like it's in a state of rest, and like the while the bus is like in the state of moving.
exactly, exactly here. Okay, look here. Inside the bus, Sundus, you and Chakrika, let's say the bus has been moving for 10 minutes and you guys have not shifted your seats. You have not switched your seats. You have been sitting at the same seat. So the time here is increasing. The bus is also moving, but still you are at the position. You both are in a state of rest because you have not changed your position now. But if I were to talk about this bus, moments ago, this bus might have been here, right now. The bus has changed its position from point A to point B now.
Yes,
Suppose
sir.
10 minutes ago, if I were to talk about this bus, if I were to talk about this bus, I'm not talking about Sundus and Chakrika here. So the position of the bus has changed along with respect to the time. As the time increase, their position also change. While
So
if I
that's
were
called
to talk
motion,
about
right?
the passengers here, yes,
So
that
that's
is
called motion, right?
that's called motion. Exactly. Here it's motion of the bus. While the passengers that are sitting inside this bus, they are at a state of rest. It's similar to you can take a similar example of we on Earth. The Earth is continuously moving now. Earth is rotating on its axis, and Earth is doing revolution around the sun also. But we do not feel it because in comparison to that motion, okay, in comparison to the rate at which it is moving, it is very less. The speed at which it is moving around the sun, it is very low. That's why we don't feel it. Otherwise you would have otherwise if the earth were to spin at a very high speed, we would fall off into the space. Anyways, coming back to the question, now what about Vaiga? She's just standing outside the bus. What would she think? What would she think? Now suppose Vaiga is standing. Vaiga, where if Vaiga were to look at the bus while the bus was at point A, while bus was at point A. So here Vaiga will see that Sundus and Chakrika both were at point A now. 10 minutes ago, Sundus and Chakrika were at point A. Now, as
Yes,
the
sir.
bus moved from point A to point B, their position has also shifted from point A to point B as the bus has shifted its position.
Yes, sir.
So, for Vaiga, who is standing outside the bus, Sundus and Chakrika are also in motion.
Yes, sir.
Yes, Sundus
Yes.
got it
Yes, sir.
right now. So, that's why we see that motion is relative. Okay. Hmm. So for motion, we need a reference point also. So Vaiga here was acting like a reference point. Getting it now?
Yes, sir.
Yes.
Okay. Then we talk about types of motion. Like motion is also of different types.
Like circular, straight.
So like
Exactly.
slow motion.
In fast motion.
That
Slow
is the
motion.
rate of motion. When we will talking about speed, we will be talking about that. Okay.
Okay, sir.
Slow speed, fast speed. If we were to talk about motion based on the pathway, some uncle is walking on the road in a straight line. So it means he is doing a straight line motion. That is another term for it. For it is rectilinear motion. That is simply motion in a straight line. Motion that is done in a straight line is called as rectilinear motion.
Yes, sir. The
Okay.
light passes in a rectilinear motion, right?
Exactly. What are some of the examples of rectilinear motion that we can quote here?
Light.
Example of light is very
Moving
good.
a car.
Sir, a
Car is
car
moving.
moving on a straight road.
Exactly. Car moving in a straight road. Okay, Sundus, you also give one example.
A cat walking on a street.
Cat walking on a street, but on a straight pathway, no? Hmm. So these are the examples of rectilinear motion, right? Then next type of motion is circular motion. Circular motion. Okay, so suppose you take a thread here and you tie a piece of stone on the other end and you swing it in the air.
It's a moving of a pendulum.
That we'll be discussing. That is a example of a periodic motion that we'll be discussing in a moment. Okay, so if you were to take a piece of thread and tie a stone on one of its end and swing it like this in the air, so the what type of motion this piece of stone is doing? It's a
Circular motion.
Circular motion.
circular motion.
So
Right
will
now,
roller coasters come in circular motion?
roller coasters, yeah, they also do the circular motion. Okay,
So
Okay, sir.
like
But
a
in
there
only
car like
particular.
in a roundabout, I guess.
anything that moves around about, okay, in a circular pathway,
Yeah.
that is said to be
Sir,
doing a circular motion. Yes, Chikrika.
sir, not all roller coasters can be in a circular motion, right?
Uh, will you please repeat?
Not all roller coasters can move in a circular motion, right? Like circular, yeah, motion.
Not
Because
not all, not all. Okay,
Some of the roller
So
coasters.
like playing
some of
football.
them.
So the planets which are rotating the Earth. Sorry, sun.
Yes, Earth's axis on a rotation of Earth on its axis. That is
sir,
also an circular motion.
Yes, sir.
Merry-go
merry-go-round.
merry-go-round, that is also an example of circular motion. So in the circular motion, one interesting thing to note is that, for example, as you said, merry-go-round somewhat looks like this, no? If you were to look at it from top, it will look like this, right now.
Yes, sir.
There's a center. This is the center. Okay, and the whole body of this merry-go-round is moving around this center actually,
So
right now.
like I doing hula hoop,
Do we
doing hula hoop.
doing a pull out? No, That won't be an
No, no,
example of.
not a bullock, like a hula hoop.
I didn't get it. Please repeat.
So like doing a hula hoop. It's like a
Hul-
ring that you put in your body and like it moves. A
Mm,
hula hoop, sir.
I haven't heard of that. Okay. Will you please explain what is that?
So it's like a ring type of thing. Like you have to put around in your body and like if you like move
Okay,
it,
okay. Got it,
a
got it,
hula
got it.
hoop.
Hmm. That will also be an example of circular motion. Okay.
So the
So
rotating fan will be
which one?
the rotating fan.
Rotating fan also. That is also an example. The
Sir,
common
the
thing
hands of
about
a clock.
the hands of a clock. Okay. And all the examples which you guys have coded, there's a axis around which the motion will be occurring. There will be a center point around which the circular motion will be occurring. Without the center point, there will be no circular motion right now. So whether it's the rotation of Earth on its axis, okay, the Earth is actually moving around its axis. Okay, so there's a center point for Earth as well, right? If you were to move this piece of stone tied with the thread, in that also, from wherever you are holding it, that is its axis, that is the center point. So in the case of circular motion, an object does a circular motion around an axis, then it is said to be a simply circular motion. So we say that when an object moves in a circular pathway, okay, around a point or an axis. Got it now? So that is simply circular motion, and you have so many examples here. Okay. So examples would be rotation of Earth. Okay. You guys tell me, does sun also rotate or not?
So
It
no,
does.
the sun does not rotate.
Sun does rotate.
Sir, it does.
Like
Because it has its own axis. I
Its
mean, like
own
it
axis.
rotates on its own. It rotates
Hmm,
on its own axis.
exactly. Actually, there are no storms on sun also. Suns also have got storms. Okay. So it was studied that the position of the storms, okay, in line of sight, basically, if you were to understand it like this, the position of the storms of the sun were seen to be shifting. Okay. Thereby it was concluded that sun must also be doing rotation. Getting
Sir,
it
can
now?
you say again? I couldn't hear your voice for a moment.
Yeah. I basically said that up till 1990s, it was believed that sun does not rotate. Okay, it's the planets that rotates and does revolution around the sun. But after 1990s, um, the spot on the sun was studied. It was basically a storm on the sun. Okay, there was a very gigantic storm on the sun. When it was studied, it was seen that the position of the storms was shifting. Suppose this is your sun here, the storm is here, let's say. Now, after some time, the storm shifted here, and after some time, the storm was not visible. So it was basically concluded that the sun is actually doing rotation. That's why this storm disappears and it moves from one place to another. It appears to be moving. Why? Because the sun is also doing rotation on its own axis. So we
So,
can
sir,
take that example also.
sir,
Circular
the
motion.
storm was always present on the sun.
It's always present on the sun. Okay,
Okay,
it's
sir.
always present on the sun. Yeah. Then you will be having third type of motion, that is called as, like you have seen things like the uh, pendulum, okay, or a fork. If you were to hit a fork, okay, strongly, or if you were to see have a tuning fork, okay, and hit one of its end, it will start to vibrate like this, in this manner. Okay. Or if you were to attach a piece of spring on a wooden table and pull it from one side, then it will do a motion like this. It will move towards this in this side and then this side and like this. Here I have tied it. Okay, it's attached. You have attached a piece of a spring on any surface. You pull it from one side, it will move to the another side in a to and fro direction, in forward and backward direction. Oh,
So will the bouncing ball will come in that the bouncing ball?
exactly. Bouncing ball will also be in such an example. Okay.
Okay, sir.
Then you have examples of like pendulum. So pendulum is doing a particular type of fashion in a fixed amount of time. Okay. For example, earlier like the clocks used to have pendulum. Nowadays it has been replaced. It's no longer used in the clocks. Anyways, the part of the discussion here is that this pendulum here, let's say it is like this at point A. From point A, it will move to point B, right? Then it will move to the point C now. Look at its way of motion from point A to point B. First, this pendulum is moving from point A to point B, and from point B, it is now moving to point C. All right, and then it comes back to its initial position, that is point A. Yeah. So this in this you see a particular type of motion is being done by this pendulum, and this will be taking a fixed amount of time. Suppose it might take 2 seconds, it might take 3 seconds, or it might take 4 seconds, depending upon the clock. All right. So what do we observe here? In a fixed period of time, a particular type of motion is being done. In a particular fashion, motion is being done. So here also you see this bob, this ball here, it is called as bob. So the bob of the pendulum is moving forward. It's moving here forward and then backward and then forward. So the third type of motion which I am saying is it's
So
called
that
as
is yes, periodic
that
motion,
is
right?
periodic motion, right?
Yes.
That is a periodic motion. So in which the objects performs a particular type of motion in a fixed time of in a fixed period of time, and obviously it does a to and fro motion. Okay, so you have many examples of it. Okay, you have example of hitting a tuning fork. Okay, then you have example of pendulum. Getting it now? Okay. By the
So
way,
periodic motion means